Hello. In this video I'm going to show how to solve a particular type of question that occurs in GCSE Maths. A question like this: prove that 0.09 recurring is equal to 1/11th. Now, there are variations on a theme here, but this is the basics, and often the question will look something like this. Okay, so we'll leave that there, and we're going to do some groundwork first to build up to this. So, first of all, let's look at a much simpler example. Prove that 0.5 equals a half. Now, you might think, well, that's ridiculous. It's just true. How can I possibly prove that? Well, I'm going to show a technique here which we use in the more complicated examples above. Okay, so basically what we'd say if we were trying to prove that 0.5 as a decimal is a half as a fraction is this. We would say, okay, let's let x equal 0.5. So we start by assigning the decimal to the value or the letter x. Okay, then we'd say, okay, if we multiplied both of these sides, both sides of the equation by 2, then we would get the answer 2x equals 1. And then by rearranging this equation, if we divide the left hand side by 2, and therefore we must divide the right hand side by 2, we end up with x is 1/2, which is a half. And we've proved that that's therefore true. So this technique of assigning x to the value of the decimal and then multiplying this equation in some way to remove the decimal place, so you just got integers, and then rearranging to create the fraction, is the same technique as we use when we use recurring decimal proofs as at the top of the sheet here. So let's just erase our very simple example and now look at probably the most common recurring decimal there is. We'll come back to our 1/11th in just a sec, but let's have a look at another one. Prove that 0.3 recurring equals a third. Now, before we go any further, we ought to just explain what this 0.3 recurring is. So 0.3 recurring is this: 0.33333 forever. There is no end to it. It recurs to infinity. And because we can't really write that down, we have a notation, and we use this little dot. So we have 0.3 with a little dot above, and that means that this 3 recurs forever. You'll notice in our question we're going to come back to here, there's a dot above both the 0 and the 9. What that means is that this number is 0.090909 and so on. So we have here a 2-digit recurrence. Each of the 0.9 keeps repeating, so it's a 2-digit recurrence. In our example for the third here, we only have a 1-digit, which is slightly easier. So let's use the same technique as we use for a half. We're going to say x equals 0.3 recurring. So we're assigning the decimal to the value x. Now in this case, we now need to work out how to multiply this to get rid of the decimal. In fact, we want to get rid of the whole recurring piece. And the rule to remember here, you'll see how it works, but the rule to remember is that we want to move the decimal place beyond the first recurrence. So if I use the 0.33333 version here, I want to move this decimal place along as many places as I need to before I've gone beyond the recurring value. Now there's only 1 digit recurring here, so it would just be 1 place to the right, 0.3. Yes, the 3 beyond the decimal point here. Notice that in the 2-digit recurring one here above, I'll need to move it twice to this position, because then only then am I beyond the recurring 0.9. So that's the rule. You need to multiply the recurring decimal by as many tens as you need to get the decimal point beyond the recurrence. Okay, so we'll use that here. So we're going to move it just once, which means multiplying by 10. And so if we multiply this side of the equation by 10, we must also multiply the other side of the equation by 10. Okay, now if we do that, then we get on the left 10x, because x times 10 is 10x. On the right, 3.3 recurring. Now, what we can do now is take away the x from the 10x. So 10x minus x is 9x. In fact, what we're really doing is we're saying, let's take away equation 1 from equation 2. So 2 minus 1 is what we're doing here. Yep, that's 9x, and then if we take away 3.3, so we take 3.3 and take away 0.3 recurring, we end up with just 3. Now that means that x is 3 over 9, and that simplified is 1/3. So we proved what we were asked to prove up here, that 0.3 recurring is the same as the fraction 1/3. Okay, let's practice this with a different one now, with the one at the top, the original question. Okay, let's rub that out. Okay, so we're going to go for the real deal now. Okay. Now you may want to pause the video here, try it yourself, and then see if you were correct. Okay, so we're going to say x equals 0.09, and both of these digits recur. Okay, so the rule is we need to multiply this recurring decimal by however many multiples of 10, so this would be multiplied by 10, this would be multiplied by 100, however many times you need to get beyond the repeating decimals. So here we've got 090909. So to get beyond the first repeat, we need to multiply the whole of this side on the right by 100. Okay, so we'll do that. We'll multiply this side by 100 and the other side, the left side, by 100. So on this side, if we multiply by 100, we'll end up with 9.09 recurring. And on this side, we'll end up with 100x. Okay. So then we've got, let's say this is equation 1, this is equation 2. 1 minus 2 equals, so 100x minus 1x is 99x. 9.09 recurring minus 0.09 recurring is 9. So rearranging this, we end up with x is 9 over 99, which is 1 over 11, which is what we were asked to prove. Perfect. Now, what might you be finding in any way confusing? One possibility I have thought of is the multiplication by 100 here. Let's just cover that one in a little more detail, just alongside the calculations here. So, this, if we write it out fully, is 0.090909, etc. If we multiply this by 100, the decimal point will move 2 places to the right. It'll move from here to here. And if we rewrite that out, then we end up with 9.0909. 09, etc. And that is 9.09 recurring. Okay, which is what I wrote there. Hopefully that makes sense. Okay, so that's the next to the hardest example. There is one further example which is just even slightly harder, and I'll cover that next. So we'll just rub that out, in fact the whole thing out, because we're going to have another example. we're going to look at finally the most complicated one that I've seen in exam questions. This is a real exam question taken from Edexcel IGCSE January 2013. And it's the question was, show that 0.17 recurring equals 8/45. Now what I want to draw your attention to here is that this looks a bit different because there's not a dot above the 1 and the 7, only above the 7. So let's proceed as usual and see how far we get. So we've got x equals 0.17 recurring. Now we say to ourselves, okay, I want to get the decimal point just beyond the first repetition, or the first digit which is subsequently repeated. That's what we said the rule was before, and it's the same here. So we're going to move the decimal point not once but twice to get beyond the first 7, and then all the other 7s are the same after that. That means multiplying by 100, so we end up with 17.7 recurring, and over here we're going to have 100x. Now the problem here, as you'll see, is I can't take 17.7 recurring and take away 0.17 recurring and end up with just say 17 like we have before, because 0.17 recurring is not the same as 0.7 recurring. They're different, so it won't just disappear if I subtract them. What I need to get is another equation which will have 0.7 recurring at the end. And the way to remember this with a problem like this is to do another multiple of x which moves the decimal point just before the repeat starts. So we've gone just beyond with the first equation here. We need another equation which will take the decimal point to just before the repeating pattern begins. And you can see here I just need to move it once, so that's 10 multiplied by 10. So our next equation will be 1.7 recurring, which is this one here multiplied by 10, and because I've multiplied the right hand side by 10 I must also multiply the left by 10. Okay, now I've got two equations which if I subtract 2 from 1 I'm going to get rid of my 0.7 recurring because it's the same in both numbers. So 1 minus 2 is 90x on the left hand side, and on the right it's 17.7 minus 1.7, which is 16. It just turns into 17 minus 1 actually. We can then rearrange that to x is 16/90, and if we simplify that, dividing both top and bottom by 2, we have 8/45, which is what we were asked to prove. So we've done that, and that's the most complicated one that you'll see in IGCSE, or at least that we've seen so far in previous exam papers. Thanks for watching.